All right, everybody, today you should have taken care of your attendance quiz for the 17th. Notebook should be out and update your table of contents. Today we are talking arithmetic sequences. As a reminder, the 6 weeks will end next week. Today we're going to talk about arithmetic sequences. We're going to learn how to write the explicit and recursive rule. This is all stuff that you started kind of looking at yesterday in that packet. Today we're going to go ahead and we're going to review it first, what you guys learned yesterday, and then we're going to kind of go into writing these rules for the tables. So let's start with making sure we know our vocabulary. What is an arithmetic sequence? An arithmetic sequence is whenever basically I have a list of numbers that has a common difference. Okay, that's what an arithmetic sequence is. The common difference is my pattern. By adding or subtracting. Now, with an arithmetic sequence, since I have this pattern, I need to also be able to figure out some rules. There's going to be what's called recursive and explicit rule. You saw these a little bit yesterday. The recursive rule is this right here. AN equals AN minus 1 plus D. This recursive rule helps us get from one term to another. It helps us get to the most, probably the closest terms. So if I was at the first, it helped me get to the second, third, fourth, so on. Because the way the recursive rule works is I'm going to take whatever number I had last, and I'm just going to add my pattern to it. That's what D is. D is my pattern. Now the explicit rule is actually a little bit more helpful than the recursive rule, because the explicit rule lets me get to any term that I want to go to. So if I want to get to the first, second, hundredth, tenth, thousandth, whatever it was, I could go to any term that I wanted to with the explicit rule. Now, the way the explicit rule works is the equation is AN equals DX plus A0. D is still my pattern. All right. And A0, that is going to be the number before our first number. Okay. We are always going to be given the first term, but we want the 0th term. And you'll understand what I'm talking about here in a second. Let's go ahead to our first table. The first thing that you want to do whenever given a table is to find the common difference. So find that pattern. How do I get the pattern for these set of numbers? Well, I'm just asking myself, how do I get from 7 to 9, 9 to 11, 11 to 13, 13 to 15? Add 2, add 2, add 2, add 2. Meaning plus 2 is my common difference. Okay, so plus 2 is my D. Well, my recursive rule was this right here. So what I need to do is just change this to apply to my situation. And there we go. If I wanted to keep going, I could see with my recursive rule that all I would need to do is do 15 plus 2. And that would give me 17. Go to the next number, 17 plus 2. That would give me my 7th term, and so on and so forth. It would get me as far as I wanted to the closest terms as possible. As long as I have the previous term, the previous number, I can use my recursive rule. Now, our explicit rule by the way, I put n this time. You can put nx. It doesn't really matter. My explicit rule, I need my difference, which we said was 2. And then I need my a0. Well, right now I have a1. So how do I get to a0? I need to go backwards from 7 and subtract 2. What's 7 minus 2? It is 5. So that means 2n plus 5 equals an is my explicit rule. In other words, guys, these rules are just equations. We're just kind of coming up with equations. That's all we're doing here, is an equation to get from one number to the next, or in other words, with our explicit rule, getting from one number maybe to the 100th, maybe to the 1000th, 20th, whatever we wanted. All right, you guys try this next one. Come up with your common difference, recursive rule, explicit rule. All right, now let's see if you did this correctly. My common difference is my pattern. So 8 plus 8 gives me 16, plus 8 gives me 24, plus 8 gives me 32, plus 8 gives me 40. So my D is 8. That means my recursive rule is an minus 1 plus 8. My explicit rule would be an equals 8n. And then we said I need to get my 0, a0, but I have a1. So that means I need to go backwards 1, subtract 8, and that gives me 0. For my a0. So I can either have my explicit rule like this or just like that. It does not matter which way you put it as long as it is one or the other. All right, let's try this one now. This one, I got these sets of stars, okay? I have 1 star here. I got 4 stars here. I have 4, 8, 10 stars on the last one. How many stars would be in the third one? Figure that out. So hopefully you figured out your pattern. First was 1 plus 3 to give you 4. Then 4 plus 3 gives you 7. And 7 plus 3 gives you 10, which is how you get this third term. So since I know my pattern, my recursive rule, that one always is probably the easier of the two. Then my explicit rule would be my pattern, n, and let's see here. I'm at my first star, my very first term, so I need to go backwards 3 from 1. So 1 minus 3 is negative 2. So in order to get to that 0 term, I have to subtract 3, and that gave me negative 2. All right, you will get the rest of these notes in part 2 of the video.